and salutation. Assalamualaikum. My name is Nur Saada Masyithah Binti Muhammad Saleh with student ID 2018801774. My supervisor is Madam Diana Sirmayunie Binti Muhammad Nasir. Today, I would like to present my final year project with a title, A Fuzzy Multi-Objective Linear Programming for Bread Production Optimization. Here is the content that I will explain, which are abstract, introduction, literature review, methodology, result and discussion, and lastly is conclusion and recommendation. Several studies on the optimization of production have been performed. The simplex method was the method that is often used by the previous researcher. However, this method has limitations, some of which can only be used in cases that have one objective function. The method that can be used for cases that have more than one objective function is a linear multi-objective fuzzy program. This method is used to optimize the production of different buns, namely Hawaii bun and slice bun at Adik Bakery Enterprise, by determining the right amount of raw materials for each bun produced and to obtain the maximum profit. In this project, the final solution is done using Lingo software. By using the simplex method, because there is one limiting function that has a sign greater than or equal to. According to the research performed, the result of optimization includes the number of Hawaii bun that must be produced is 120 bun, 240 bun of sliced bun, the lambda variable value of 0.16, which indicates the degree of membership for each objective function. The maximum profit obtained is 1,140 ringgit and the minimum processing time is 105.6 minutes. In the introduction, I will present the problem statement, objective of the study, and scope of the study. This study might solve the problem faced by Adik Bakery, which is to find the possibilities for management decision to optimize the output of the different bun, to determine the correct quantities of raw materials for each bun produced, and to get the maximum profit. This analysis must be carried out for Adik's Bakery to have a solution so that its raw materials do not exceed the quantity needed. Next, for every project, it must have an objective. So, this is my three objectives of the study, where to maximize the production of a different bun, to determine the right quantities of raw materials for each bun produced, and finally is to obtain the maximum profit. The scope of study for this project is I am used the primary data from an individual business, namely Adik Bakery Enterprise, where it's located in Cemor, Perak. In order to get all the data that is collected from 2019 to 2020, I am interviewing the owner of Adik Bakery through WhatsApp application. The data that I collect is the amount of raw material for producing two different types of buns focused on this study, which are Hawaii bun and slice bun. The raw material used are bread flour, milk powder, butter, salt, yeast, sugar, water, and chicken sausage. In the literature review, there are two parts which are the method used, namely a fuzzy multi-objective linear programming, and the second part is about the bread production. Let us move on to the topic about a fuzzy multi-objective linear programming. In this slide, I have attached the definition and a few research that have been done by using this method. This shows the fuzzy multi-objective linear programming is not a new method, but it has been introducing since 2013. Next, about the bread production. There are a few research have been done by Saho Patnaik 2017, Zhang and Data 2006, and Jefferson et al. 2007. The previous research that studies on bread production using other method, but the main goals were to produce the good quality of bread based on manufacturers, such as to find the exact temperature to bake the bread, to improve the consistency of the bread, and to formulate the crust density of the bread. Mostly, the previous studies have achieved their goals and objectives successfully. Next, methodology. I will define all the variable used and the data implementation that consists of three steps. Firstly, use the formulate data processing, then add the number of inventory tolerance, and lastly, change the first goal. Here is the variable used during accomplish all my calculation at methodology part. First, lambda was denoted as degree of membership for each objective function. Second, x1 is for Hawaii bun and x2 is for slice bun. Lastly, z1 is the maximum profit for bun produced and z2 is the minimum processing time of bun. This is the table of data for my project. For an information, every bun mixture will produce 60 bun, and the formula to calculate the profit per mixture is by multiply the number of bun produced with the profit per serve. This slide shows the equation used in the first step. The equation has been formulated by data collected and run by using POMQM software. Next, this is the equation used in the step 2 by adding the number of inventory tolerance by using the same software at the first step. In the last step, the first goal will be changed, where a new model is formed with the aim of maximizing lambda and adding the two objective functions to become a limiting function. This slide shows the new equation obtained. Step 3 was run by using Lingo software. Result and discussion. This slide presents the result obtained in the step 1 and step 2. Based on the first figure, it shows the value for lambda, x1 and x2 that has been rounded off to the nearest value, since the value is for a bun mixture. The Lingo software cannot read the lambda symbol, so that I have denoted lambda as x1. Then x2 is for Hawaii bun and x3 is for slice bun. Thus, the value for lambda is equals to 0.16, x1 equals to 2, and x2 equals to 4. Then, according to the next figure, the value for the processing time, namely Z2, is 105.95 and the rounded off value is 105.6 minutes. For the last step, it was run by using Lingo software. This is the summary result for step 3, where the final value of lambda is equals to 0.16, x1 equals to 2, x2 equals to 4, z1 equals to 1,140 ringgits, and z2 equals to 105.6. This means by producing 2 bun mixture of Hawaii bun and 4 bun mixture of slice bun, the Adik Bakery Enterprise will get a maximum profit of 1,140 ringgit with a minimum processing time of 105.6 minutes and a variable value of 0.16, which indicates the degree of membership for each objective function. Conclusion and recommendation. The conclusion is objective of the study has been successfully achieved, since the maximum profit by producing 120 of Hawaii bun and 240 of slice bun with the 105.6 of minimum processing time is 1,140 ringgit. For the recommendation, the data of this study only used 2 types of different bun, so that the method used was also limited. Thus, by recommendation, for another study, should be done by adding more different type of bun and trying another developing area. All the information can be directly interviewed with the owner or by searching on the bakery's official website. Lastly, this method also can be performed by using Lindo software and Microsoft Excel. Thank you for lending your ears, and that's all from me. Assalamualaikum.